Okay, looks like we can start. Um, yeah. Okay, I'm going to start. Good afternoon, everybody. Thanks for the attendance of this group of talks called Open Collaborative Paradigms. The open source movement is a disruptive paradigm that is changing the traditional understanding about technology, ethics, and freedom in many areas. To know more, starting today and during the next month, we will have 5 presentations with the leaders of different open source projects oriented to architecture and BIM industry. My name is Rafael Moya, and well, before to present our first speaker, I just want to thank the support of FAUC de la Universidad de Concepción, Facultad de Arquitectura, Urbanismo y Geografía, and its Unidad de Vinculación for the help to organize this presentation. Yeah. Today, the presentation will be about BIM workflow in Freecad. Freecad is a powerful parametric 3D CAD software developed by a community of users and available free for everyone. It is a tool that is used by thousands of people around the world. I want to introduce Jorik van Havre, an architect and one of the main developers of Freecad and its architecture and BIM model. In this presentation, we will show us his work on Freecad and how he used it for architecture and BIM workflows. About Jorik, born in 1973 in Belgium, graduated in architecture in 1995 at Institute, I don't know if you can read it correctly, Institute Superieur d'Architecture in Saint-Luc in Brussels. Jorik van Havre has lived in and worked in Belgium, Japan, USA, South Africa, Mali, and Brazil. Currently, Jorik works in his own architectural studio, Uncreated, and also he is a collaborator for the studio Opening Design. Since 2008, he is one of the main developers of the open source and parametric software Freecad. The idea is to have the presentation, and after we can have some time for questions. You can write them this question in the chat panel of this channel at the right hand. And after the presentation, I can read this question for Jorik and he can answer. Okay, so thank you, Jorik, for your time. And for this presentation, we are really happy to have you here. And as well, we are ready to start. So when you want it, we can start.
Okay, can you hear me? Is everything okay? Okay, then let's go. Then thanks for inviting me here. It's always a pleasure to speak about Freecad and to showcase a little bit of it. Since I'm the first one of your series, I think I might take the opportunity to do a very short introduction of free software and what this is all about. I think the best way is to tell a bit about how I came into this. Basically, I'm an architect. And when I began my own architecture studio, I faced the same thing as basically everyone who starts their own practice. The price of BIM software was unpayable. I was living in Brazil at that time, and we had a two-person studio, and paying the license for BIM software was the same as hiring 2 new people. It was just impossible for us. Then I began to look for free solutions or cheap or free solutions to do architecture. And basically there wasn't any. There were some free things here and there, but that was that kind of scheme where you never know how long it will stay free. You begin to use a shareware, then the next day it becomes paid, or they remove features, and it was like unpractical. And then I discovered Freecad, which was really starting, and I began to learn about free software as well. Free software actually is much more than being free. In English, the same word free is used to say you don't pay anything, or to say something is like in freedom. In other language, we have a different word for these two things. But when we mean free software, we mean freedom, not free beer. That's what the creators of the free software movement, that's how they explain it. So I begin to know about free software, and that's really much more than being just something that you don't pay. Free software basically is also open source software. Is software that is developed by a community. That means it is developed by users and not by a company which tells you what tools you should use. In free software, usually tools are developed by users primarily. So this is completely different. There is no commercial aim behind it. Things that are made by people who use these things. So they make it in their own interest, and that's really what makes everything completely different. When you use a proprietary software, usually they want to lock you in. They want you to use only their solution. They want you to buy other of their products. In free software, nobody has any interest in selling anything. So basically, we try to integrate our software with other software. We try to make all these things work together. We don't care if someone prefers to use another software. It's welcome. Nobody here is selling anything. So I really got hooked with that, and I began to learn to program. And since 2008 something, I'm just I never stopped working with Freecad and developing Freecad, etc. So I will give you, for who never heard about Freecad before, I will show a little bit how that works. Let me share my screen. Okay, I hope you can see my screen now. So this is the Freecad website. Basically, this is where you would go if you want to download Freecad. You can change the language to Spanish. And there is a quick explanation about what Freecad is. You can read more about Freecad, and this is where you basically take your Freecad installer to install on your computer. Go ahead, do it. It's for free. There is no strings attached, no license that you must comply. It's yours, basically. That's what we like to say about Freecad. Take it, it's yours. To explain to you a little bit how it's developed, we have here a documentation, which is a wiki, like the Wikipedia. It's written by user, developers, anyone. It has quite a lot of documentation. Every piece of Freecad here is well explained, etc. And we have here in a forum. That's basically where everything happens. This forum is, you see, there's a section in Spanish, and there are sections to discuss about all the aspects. That's where people interested in working on Freecad, in developing Freecad, come and meet, and that's where all the decisions are taken, basically. And the third interesting place here is where the code of the software lives, which is here on GitHub, which is a hosting platform for open source code. And basically all the source, all the files that make the source code of Freecad are all here, all open. Just to show you all the code that makes Freecad is here. So basically, the big advantage of this is that even if you're not a programmer, the fact that the software is openly available allows anyone to look at it and to know exactly what it does. More than often, everybody knows that you install some software on your computer and you never know how much it is like sending some private data of yours to some company somewhere. When you have access to the source code of the program, someone who knows how to program, how to read code, can see what the software is doing under the table and make sure that it's not doing anything it shouldn't be doing. And that's something tremendously interesting with free software as well, is that you can audit it and you can always be sure about what it's actually doing. So this is basically the universe of Freecad. That's how it's being developed. On this code here, you have these pull requests, which are like people fixing things. They send for example, you fix something here, you send your code here. This is what this person has changed in the code. And some of the authorized person, there are like about 15 of them right now, would approve this change or not, approve or ask for modification or discuss, etc. That's really how the software gets developed. Some people have direct access to change the code, and the others can use this system to submit their change, and they get verified and reviewed by some of the main developers. And that's how the whole things is being developed. So this is Freecad when you open it. Don't mind my dark interface, it's because my desktop team, but if you are on a light desktop team, your interface will be light colored. So this is the start panel of Freecad. When the first time you start Freecad, you will see this with less files than mine probably. And Freecad actually has this interesting control here. That's the Workbench Selector. Basically, Freecad is not made only for BIM. It's a generic 3D modeling application. It's used by architects, engineers, but also and mainly by other people. For example, people who do 3D printing, all kinds of engineers, all kind of makers, hackers, people just wanting to model something to build it. Basically, we used to say Freecad is the main use of Freecad is to build to model things that will be built in the real world. So that goes from small electronic components up to cities, pieces of cities, and of course, including architecture. Because of that, multiple specialties or multiple uses, Freecad, the interface of Freecad is divided into what we call workbenches, bancadas in Portuguese. I'm not sure how that would be in Spanish. These workbenches, basically, there is one for working with Bing, there is one with text for working with textures, there is one to work with images, there is one to work with mechanical parts, there is one to do rendering, there is one to work with robot movement to simulate movement of industrial robots. There is one to work with spreadsheets like Excel. And there are many more. There is here we have an add-on manager where you have plugins basically that are developed outside Freecad by other people, and that can extend Freecad quite a lot. Basically, what you do in Freecad is create parametric objects. Freecad is, before anything, a parametric modeler. What is that? That is basically, let's take this part workbench and make a cube. Here is my cube. And this cube, it has here properties like length, width, or height. These properties is what we call a parametric model. I can change this, for example, this height, instead of 1 centimeter, sorry, I could say 5 centimeters, and my object has changed. I can change the length here to something else. That is basically a parametric object. That means that it's an object that is driven by properties. And if you change any of these properties, the shape of the object is updated, is recomputed actually on the fly. We have others like these, and you see this cylinder has different properties. Let's change some of them. And I can do things like a subtraction. And then I have now a subtraction that is a subtraction of my first cube, and then the cylinder. The cylinder is still there, so I can still change some of its properties like this. And you see that the result, that is, this object has changed. So you can really begin to think of a parametric model as a kind of chain of objects, each one depending on the other. And you can really build very complex model that way. That's really how Freecad works, basically. This is a very simple example that I showed you, but I will show much more complex things now. But basically, that's what makes Freecad different than other 3D applications. Basically, like, for example, Blender, where you deal with points and lines and triangles, and you move the points to create objects. And here in Freecad, you basically work with these properties. That's the main feature of Freecad. Now you have these kind of workbench with very generic tools to model basically anything. We have more complex stuff, like, for example, this one called the Sketcher is really interesting because it allows you, let me show you. I will make a new sketch with it. And sketches are 2D, two-dimensional drawings or shapes. Something like this, where you can put constraints. For example, I can take this line and I can say I want it to be horizontal, or this one to be vertical, or the same one to have a fixed length of, let's say, 3 centimeters. And now I can move these points and you see that some things are locked. This line where I put 3 centimeters cannot have a different size anymore. This one, or let's say I could take this point and this point and give them a vertical dimension. And you see that if I move these points, the constraints that I placed are like restricting movement. So you can make really, really complex shapes and drawings that way with a lot of intelligence. Like you can do things also like, for example, this big dimension. It should be like always, for example, 2 times the small dimension. And then if you change the small dimension, the big one will change its size automatically, that kind of stuff. So you can do really, really complex behaviors there, where one thing drives the other and the other and the other. And if you change one thing, all the other objects that depend on it will update. And we have, that's the gist of it, we have a Bing workbench. This Bing workbench, the way it is made in Freecad, I will show a bit of examples here. I think that will speak better than anything else. So I will get back to my start page and take an example. This one, for example. The Beam workbench in Freecad, the way we designed it, although it has the same kind of tools that you find in other Beam applications, I mean commercial Beam applications. It has tools to build walls, to build columns, to build doors, windows, roofs, all the elements that you usually find in a building. But we have tried also to keep it very free. That is, instead of having, like in many other applications, you need to use the wall tool to build a wall, or you need to use the window tool to build a window. In Freecad, basically you are pretty much free to do it any way you like. You can model any objects like this one with other tools which are not, you see, for example, this is a wall, but you're not forced to use the wall tool to build it. I can do something like this. Let's say we'll draw here shape, any shape. This, I'm using the polyline tool and close. I have made a small shape. I will extrude that shape of about, let's say, 15 centimeters. And I will say, this is a slab. and I just use the slab button and decide this has become a slab. And this is now a beam object with all the properties of beam object that you would need, IFC properties, structural properties, etc. But I have modeled it using other tools. And this is something um, tremendously precious in Freecad, that you're not forced to use beam paradigms to build a beam model. Basically, you can model stuff, beam stuff in Freecad with any other tools from other workbenches, or even with other software, and you just import the shapes or the geometry from another software, and you use that in Freecad, and you turn it into a beam model. A beam model in Freecad is basically a normal 3D model where the objects have a little bit more information, mainly basically IFC related information. What makes a beam object in Freecad different from another object is mainly its IFC type. The IFC formats, they specify, I'm not sure if you are able to see this drop-down menu, but it specifies quite a lot of different element types. You have almost anything that you could find in a building. Doors, windows, floors, lamps, fan, fastener, electric appliance, etc. And what makes a big deal of what is a beam model is giving correct types to your object. This is a wall, this is a window, this is a door, etc., etc. When you have a model where all your objects are correctly have a correct type like that, you already have done a big part of what makes a beam model basically, and not just a generic 3D model. So you can also organize your model mostly the way you want. In Freecad we have groups which are like folders, and on your computer you make folders and you put your files inside the folders. In Freecad you do exactly the same thing. You create folders, which are those groups that you create like this, and you just put your objects into your folders, and that's how you organize your model, just like you organize your files on your computer. This is really powerful. I think much better than many other paradigms that you find in other Beam applications. This is perfectly exported to IFC format as well. You can use the usual organizing or the usual structure that you find in IFC files in Freecad as well. That is basically that you need to have a building object, and inside that building object, your model is separated into levels or floors. And then in each of these floors, you have all your objects. That's basically how other Beam applications work mostly. You can do that in Freecad as well. You can use, we have a building object, a floor object, where you can put your object the same way as groups. But let's say you're not really forced to use that. And if you don't really need to do that, for example, if you don't, if you won't export your stuff to other applications, then it's of little use. I will show you another example. to show you how do we produce drawings from this model, because as I explained, one of the uses we make of BIM model is to export it as an IFC file to other BIM applications. And another interesting use, of course, is to generate 2D drawings, plans, plan views, sections, the usual drawings that architects work with. Let's open another one. And this is a heavy one, it takes a little bit of time. But basically it's interesting also because it shows you how long it takes to open a really complex model with all the plans, all the drawings in it. And it's quite similar to what you would find in other BIM applications as well. And yeah, here it is. So yes, here it is. So here in this model, we have a complete building, and some levels were turned off and turning them on again. And you see here, I have a complete, a quite complete BIM model with I hope what I'm doing is not too slow on your screen. Basically, we have a BIM model modeled the same way as I just showed you. And we have here next the 2D drawings, the plan views that we extracted from this model. How is that done? Basically, we have a couple of section planes like this, and it's basically just a matter of placing some section planes in your model. Here are the section views that were turned off, that I just turned on now, that were produced by these section planes. So basically, it's quite simple actually. You place these section planes in your model, and it creates a cut into your model and produces a view of that cut of that section basically. And here is, for example, the result. Then you can do things with those 2D views, like for example, place annotations like this one, or dimensions, hatchings, symbols like this car, text, and all other things that you usually do, that you would do. Yeah, I just switched the background to white to make it clearer. And all the drafting stuff, the annotation work that you usually do on plans, on architectural drawings. Some of these stuff you can make them linked to the original model if, of course, if the model changes this view will change as well. And then this can be exported to 2D drawing formats like DXF or DWG. Or you can place it on a sheet and produce a PDF file. Let me show you one more to show you how the output looks like. This one. And then if, yeah, we have a little bit time, I will show you a little bit on a fresh model, how the workflow actually looks like. I think that might be the most interesting part. This one I'm opening now is another project we've done with opening design almost entirely with Freecad. So this is it. Basically, this model here was not modeled in Freecad, it was modeled in Blender BIM, which is another BIM application. It was exported to Freecad, and then we used Freecad to produce all these drawings here. And then from here, basically all these plans, sections, and all these detail view also, like this one, got placed on sheets like this. So you have this system in Freecad where you can take a view of something that happens in the model and place it on a sheet with title and with borders, and the same thing we usually do with other BIM applications. And then this can be exported to DXF or PDF. And you see you can put anything you want here, texts. This table here is taken directly from the model. It's calculated, it's actually here. It's a spreadsheet, an automatic spreadsheet that takes data from the model, and then this spreadsheet can be placed on sheets, on final sheets like this one. So yeah, that's a bit what Freecad does basically. Let me show you a little bit of how the workflow looks like. This is something I was beginning. This is a famous house in Brazil that is called Vila Matilde house by Terra e Tuma architecture office. It's in São Paulo, and have a look at it if you don't know it. It's really super interesting project. And what I've started here just as a kind of training, and I will do a little bit more on it. So what I've done here, basically I've taken, let me close things I'm not using. To free up some memory space. I hope you saw that I was able to open like 3 or 4 semi-heavy models at the same time. Try to do that with other commercial BIM applications. Freecad that's another advantage of using free software usually, is that they are usually much lighter than commercial applications, and so they would run on older computers. They will never force you to update your computer because the application is becoming too heavy for it. And they're quite low on computer resource usually. So you can do these things that are hard to do with most commercial Beam applications, that like open 10 models at the same time and do copy and paste between these and this kind of stuff. So that's really another nice point of working with free software. So here, for example, what I did basically is I grabbed images of this house, the plans of this house on the internet. This, you can see that it's an image that are placed on the background, and since it has a graphical scale here, I was able to scale it the right size. And so I began to model stuff here, and modeling walls is quite simple. Let's start again to show you how I did this. Once my drawing is up to scale, I can use the wall tool like this and draw a wall. This is a simple wall. I can get it here and change its properties. Like, for example, I could change its width from 15 centimeters to 25, or change its height, let's say 2 meters and 50. If I open this wall, you see that it has created a baseline that you can see here. That is the same behavior that I showed you earlier. Basically, a wall is based on a line, and it uses that line to construct the geometry of the wall. So I can do that manually as well. I can also come here and draw a line. Let's say I will model this external wall here. You see that I'm more or less snapping to things, but not really precisely, because this house is so simple that it's completely modularized. All the dimensions are based on the same module, and here I'm doing things rather erratically. So probably the day I would want to do this perfectly, I would choose another method. But now, for example, that I draw this line, let me make it thicker so you guys can see it. Where is it? I could use my wall tool to build a wall on top of it. Only it's on the wrong side. So let's fix that from right to left. And it should have a width probably of 20 centimeters, I guess, by the look of it. And so I've modeled my wall here. Let's model a couple of internal walls. For example, this one. For this one, I could do the same thing. Draw a line, pick my line tool, draw a line here, and then take this line and turn it into a wall. Or I could use my wall tool directly and start my wall from scratch. You see that the result is exactly the same. I don't know what that is. That's wrong. Let's, for example, do these two walls here, and then we could make a window in the middle. So this needs to be left. and do another one here. Here I have a kind of complex window, and I could use my window tool to make one, but probably I don't have the preset to do such an interesting different window which has very different parts. So in this case, I could, let's try, I've placed here my section view. I've rotated my view, and I could basically draw it here directly. Let's say, for example, this piece here. I will place, before drawing, I will place a couple of guidelines. You see that I've placed one vertical here. That will help me to model this thing correctly. So now I have lines all around the piece of window I want to make. Using an intersection snap to hook a rectangle here. I will deactivate the face that this rectangle is producing, and I will simply make another here. I will do things rather by eye here, just to show you how it works. But of course, I would make this more precise. Would I do it? And what I will do here is extrude this first rectangle by, let's say, the thickness of windows, for example, this, and then all these will be extruded by, okay, by 15 centimeters. Now I have one external piece and 4 inner pieces. And I will just subtract the inner piece and the outer piece. We have, of course, and then I have this window here, and I still need Windows panes in it because I just have the frame at the moment. And then let's take back our inner rectangles. 1, 2, 3, and 4. And I will again produce extrusions of these 4, this time 1 centimeter, to produce 4 glass panes. And I will move them a little bit higher. And even better, let's make them transparent. Okay, now I have modeled a window. I can place all this inside a compound object that is a kind of grouped object, and this we will rotate here it is. So now we need to move this on the ground. And you see that we are exactly at the right position. This compound, now I want it to be a correct beam object. And the only thing I need to do is to use the window button on top of it. And it's now a real beam object with all its IFC properties that you can see here. All the attributes that a window normally has. So basically that's how you work in Freecad. You can use predefined types as well, just to illustrate that it exists. If I use the window tool without anything, I have a couple of, without anything selected, I have a couple of presets. I could do something like that as well. Let's say, for example, let's make a window this size. Oh, it's made a hole where it shouldn't. Let's fix that. All right. Let's move this window somewhere here, and move it again somewhere here. So that was just to illustrate that you can use the standard beam tools of Freecad and model the same way you are used from other BIM applications, but the real strength of it is that you can model any way you want. You can model such a windows with cubes. You can make one thin, long cube to become the upper part of the window. Then you would use other cubes to model the vertical parts of the window, etc. And you could think of hundreds ways to model a window like this one. And so that's basically the big strength of an application like this. I think I've basically come to the end of my time. So I would suggest to stop here and to see if we have questions, and maybe Raphael, we could if there is something you would like me to show better, we could do that, or answer questions.
Sure. I have some questions here, and I'm going to translate them so you can answer them. First, there is a question about this is a software that is open, so you can hack, you can transform, adapt it to your own workflow. You can create tools and features inside this software, and it's totally legal, and that is fine. Like what you are doing, with this Arch module. So we know there are other developers working as well in versions of Freecad with more visual features, and so we have one question from Nick Helmut about if there is an idea or plan to integrate the Real Thunder visual things like shadows and other features that he is working on in the official Freecad software, so we can, enjoy this visual characteristic for our Arch workflow.
Yeah, of course, yes. We all like what Real Thunder is doing, and the answer is, of course, yes, we want, and we will get there. Just to explain a little bit for people who don't know the story. Basically, since the Freecad source code is available to everybody on the internet, and that you're allowed to take this code and do basically what you want with it. So you can take the source code of Freecad and make your own application somewhere. The license that comes with Freecad, which is the important part of any free software, is its license. Basically, the license of Freecad, the same that it's used by many other free software in the world. Basically, it lets you do anything you want with it, except that it doesn't let you use it in a commercial application, that is in a closed application, without saying it to the user and allowing the user to know it. That means for example, that you could take Freecad and make a closed proprietary application with it and sell it. You can do that. The only thing you cannot do is hide to the user the fact that you're using Freecad inside. So users should always be able to know this application is using free software. I could go there on the website and find what this is about, and maybe I'm more interested in using the free version. And that's basically the only thing that the license forces you to do. So it's free for anyone, you to take Freecad and in your own corner to do modification and to do another version. You decide, for example, that all the thing that I showed you here, it's all wrong. You want to do it completely another way. You can. You are not even you can, but this is cool. This is good. This is good for the ecosystem. It is good that many people come at the same problem and try to solve it different ways. This only benefits the software, users, everybody. So since a year or two, we have this guy who his nickname on the internet is Real Thunder. And he is really a very bright programmer, and he goes very, very, very fast. He programs like lightning. He has done lots of improvements to Freecad. Only problem, he goes so fast that his changes are gigantic, and it's really hard to integrate them back into Freecad without breaking everything. So this is a process we do with him very carefully, and it goes slowly because we need to test, we need to check, we need to make sure it doesn't break anything, etc., etc. So all the work that Real Thunder is doing will get into Freecad sooner or later. Nobody is against that. Only it takes time because what he can do on his corner, he can go very fast, and if there are bugs, he will see what it does. But the version of Freecad that we have, that I showed you, It's now used by companies, by a lot of people who use it as an engine for other applications. So we must take real care to not break anything and to not have tomorrow something that this functionality is broken. We just cannot do that because people rely on Freecad now. So we need to be extra careful to review anything before that's why it takes so long, basically.
And a personal question based on what you are saying. These things that is for us in Latin America, it's very strange. An architect that at the same time write code. What is this? What do you think is a good idea to maybe start teaching coding in university in architecture school to allow the student manipulate and create their own tools?
Yes, I think it's a question that has two parts. One part is a problem. One part is the problem is that many people believe to use free software, you need to be able to program. If you cannot program, you cannot use free software. It's just too complicated. And this is a hoax that you hear a lot. And I hear that every day. And some people from maybe some companies, I don't know, but say that a lot. And this is wrong. The aim, I think, I tried, that's something I hope I could show you with what I showed you with Freecad here, is that you don't need to program to use it. Any well-known open source application, like for example LibreOffice, you don't need to program to use LibreOffice. It's like normal Office. Linux, you don't need anymore to program to use Linux. You don't need to type stuff in terminal windows. Basically, nowadays, all these applications, you use them the same way you use any other desktop application. So I would say there is some myth that we need to break here, that no, this is made to be used by anyone. And this is an important part of free software also. It is made to be used by anyone without any background. You shouldn't have programming background to be able to use free software. And the aim of it is to be used by everyone. So this is an important part, I think. Now, there is something, an opportunity, a real amazing opportunity here to take our tool in our own hands. If you buy BIM or CAD software from a big BIM vendor company, the tools that you use to do your job are defined by a commercial person somewhere in the United States. The decisions why, let's say, if this feature will be in the software or not, this decision is taken mostly by commercial goals in mind. They try to sell a software. When we work with free software, we have the opportunity to design our own tool. And if you ask, how do you call that, a lumberjack, the person who hacks trees in the forest, this person will be the best person to know how his tool must be, how his axe must be. He would be able to tell you, no, it needs to be this long, the head must be this heavy, and that would be the best person to define how the tool must be. And it's the same for us. We architects should be the best person to define how our architectural tool must be. We should decide that. We should define that. We should decide this needs to be done that way. And learning a little bit of programming and I assure you it's not difficult. The programming language that Freecad used, there are two. There are C++, which is a complicated programming language. Half of Freecad is made with this one. It's basically all the base of Freecad because it's a fast language to process 3D graphics, etc. You need a very fast system. But all the rest around it, all the interface, all the tools that I showed you are programmed in Python. And Python is a language that the creators of the Python language called, this is a programming language for human beings. And it's really that, it's easy to learn. In 4 hours in an afternoon, you learned Python. It's really very simple. There are 20 or so keywords and a couple of concepts, and that's it. And the code of Freecad is there. There are people to ask, I see this tool here and I would like to change just a little thing. Some people will help you to locate where it happens in the code, and you would be able to understand what to do quite easily. Some people will help you. There is a forum, there is a community. And so you have a very, very, very close and easy opportunity to start working on your own tools. Take your axe and begin to test. Is it better if the head of the axe is heavier or not? And it's really, really not very far, even if you never thought about programming before. The steps or the way you need to take to get there is really, really small. And that's really, really an opportunity where we should begin to think, definitely.
I have another questions. We have some minutes, so first, Claudio Solovera, he wants to say thank you for the work on developing this BIM tool, and he has several questions. Some of them you already answered. One of them is, what about, is possible to use Freecad on a tools? I am trying to interpret this because it's a very long question. What about to use Freecad as a tool for social approach, as a project with a social approach, not commercial approach, like a use for technology to help people in need, like after disasters, the people lost houses, and we need, technologies to provide design quickly and fabricate these houses. Maybe Freecad can do something in that area. And the second question is, what about the workflow with private formats? In your case, for example, how you deal with these private formats coming from a commercial program in your work?
Mm-hmm. Okay, then the first part of the question, of course, that's what we all want to do with Freecad, and I think that's where something like an open source application can do, basically can change the whole game, where you can have communities that have no money to buy to buy expensive software, and also no knowledge to use proprietary formats, to use BIM concepts, and to do a project let's say the proper way, like we used to do as architects. You could have people from communities who have no formal knowledge of construction, but who know how to construct. They know how to build a wall. They know how to put a concrete slab on top of a wall. And they maybe won't use an expensive commercial software, but they could use Freecad. People who work with wood could take Freecad and start using it. The big, I would say 70% of Freecad users are home user who want to model things to 3D print. For example, you have this electrodomestic, a blender, for example, and you break the button and you go there with your how do you call that, your meter, your tool to measure, and you measure the size of the button and you model it in Freecad and you print it in 3D, and then you have a perfect replacement for your button, and your blender works again, and you can really think architecture that way also, something that people can hack and tinker with it and fix and change some parts. And this is really, really hard if you think, okay, to do that, the person will need to go to a process of contracting an architect and do that and learning a whole new way of doing things. But if they could take something like, imagine that all files are available in open formats, that they could take an open source application, install it and modify these things. This changed the whole game. You could have really take the project a little bit out um, of the world of architects, engineers in the industry, and have people take a bigger part in it. And I think free software has a big role to play there. The second part of the question was about proprietary formats. Yes, that's really a problem. To give you an idea, for example, proprietary formats like DWG, for example, that's an old format for drawings. You don't know what's inside. It's a big encrypted thing. The Autodesk, the firm who published that software, they don't publish any information about the software. So you could do is reverse engineer. Like say, let's draw a line, save the file, let's move the line, save the file again, and let's try to find between these two versions of the file what has changed. And then, but it's a big gibberish of letters and numbers randomically. So it's really hard to decrypt these language, these formats. Basically, we would put all our efforts in doing these things, and the next year they would change one little thing, and all our work would be lost because we would have to do it all over again. So basically, for a free project like Freecad, trying to support proprietary formats is a bad idea. We would lose all our efforts in trying to do that. What we do in Freecad, basically, if you look at how many file formats Freecad can import and export, you have like 50. It's really a lot. And some of them, your proprietary application will take too. So that's how most people work with, try to find intermediary formats that work between both. And you have some projects that try to specifically try to reverse engineer some formats. For example, there is a project called LibreDWG, which is a project that creates a library to read and write the DWG file format. We use that in Freecad. So when we see other projects, other free software projects that tackle some specific proprietary formats, of course, we can use that. That's the beauty of free software. You can reuse pieces of other free software projects. So it goes, but not, let's say it's far from being a priority, and it goes as much as some other projects are interested in doing that as well.
I think we can go with just two more questions. And Alfredo Angeles, Freecad Beam, Workbench, Blender Beam, and IFC, these libraries for Java. Do you know each others? Do you collaborate to join those projects? That's one question. And the second question is about from Nikki Helmut again. What is the future of Freecad? What happens if Open Cascade, that is the engine of Freecad, become closed, private? What will happen with Freecad? Will be free forever?
Okay. The first question, yes, definitely. We don't not only know each other, but there are lots of efforts to collaborate. Dion Mood, the guy behind the Blender Beam, has worked a lot on Freecad as well. There is a lot of code in Freecad which is by him. And now we are looking, I would really like to integrate parts of Blender Beam in Freecad as well. There are things that are really nicely done there and that would benefit Freecad as well. And that's the beauty of free software. All of this is possible. Requires a little bit of technical work and tweaking, but it's doable. And it's doable technically and it's doable legally. There is no legal problem with doing that. You can. The license of these softwares permit reusing a piece of one into the other. And that's really, this license is really the founding part of all the free software movements. It's what these license permits and also what they guarantee you. And that leads us to the other question. What happens if Open Cascade, which is the geometric engine of Freecad, which is another piece of another project of free software, what happens if that project becomes closed tomorrow? And well, that's the beauty of it. It has the same license as Freecad, which basically says, yes, they could tomorrow take all the authors of Open Cascades, and there are not many because it's developed inside a company. So basically the company has the rights over the whole code there. They could do that. But the code that has been already published with an open source license, they cannot take it back. I have a copy of that code here on my computer, and I have the rights because it comes with a license that say, you, Yorick, have the right to use that code any way you like, which is the same license of Freecad. So they could take the next version of Open Cascade and close it. But this one that I have here on my computer, they cannot close it. The license says this is open source software. So what would happen probably if they would do that? Immediately someone would take the last open source version and start a new project from it. And we would start using that project because there are many open source projects using Open Cascade. So it's already part of a big open source ecosystem. And so the next day, if they decide to close it, a new project with an open source version of Open Cascade would appear. And it would be legal because the version that we all have up to now allows to do that. So it's basically, that's the beauty of it. It's really hard once a project is part of the ecosystem to remove it from it. And this is a special case because Open Cascade is developed in a company. But for example, the case of Freecad, there are more than 200 authors or owners of the Freecad code. So if we would decide, let's say a couple of us who are evil, decide to close and to start selling Freecad, we would need to change the license. We would need the authorization of more than 200 people, which is impossible. At least one will say, no, I don't want Freecad to become commercial. So Freecad itself is basically guaranteed to never be sold. It's almost impossible. And even if some company would want to buy it, that company would need to buy from 200 people. Certainly, I guarantee that I won't sell my part. And certainly many others would do the same. And so it's unbuyable, basically. So in other words, it's guaranteed to stay free forever. And there will, in the future, there will be more authors. It grows every year. So it becomes more impossible every year. And so it's a really nice ecosystem where the legal part of it is really important. That it's what guarantees that it has strong foundings, and that's the big difference between free software and freeware. And many people don't see really, but it's all free. What's the difference? And the difference is that it's the license. Um, Free software, freeware is just one guy giving you a software for free, but you have no control over anything. And free software, the important part is not the price, is the license. And that changes everything.
Wonderful. I think just let the people know that about these other projects like Blender Beam and IFC, these libraries in Java, we will have as well, we are working for that, invite the leader of that project to this group of talks so they can show us what they are doing, as well how they are collaborating between them to change the paradigm about how BIM is being developed in this in the industry. So I think it's fine. It's we can finish here, and here. Sorry, I have one more question from the director of the university, the school of the university. He said, congratulations, thank you for your talk. My question will be if Freecad is able to export to IFC format, which is self-open, no? So that will be the last question. Can you?
Yes, of course. IFC is, for me as for others, that's the most important part of an open source BIM ecosystem, is the IFC format. It's the first time that we have a same format for everyone, and that format is open. You can go on the internet and read how that format must be written. An IFC file is a text file. You can open it in the notepad of Windows. And so if in 20 years, all the applications that you use today are gone, you will still be able to open your IFC file and extract the content somehow. So yes, that's, of course, that's the first thing we did when started working on BIM in Freecad, is work with IFC. In Freecad, how that works, I would say, without false modesty, it works very well. I would dare to say Freecad and other free software deal with IFC better than, I won't say names, but big Bing applications. And if you work with big Bing commercial applications, you know that IFC is full of problems. And I dare to say we have much less problem in the open source world, because we all basically use the same libraries to import and export IFC, which are really good and strongly made. And yes, I would say usually you have no problem with IFC in Freecad. You press the import button to import, press the export button to export, and all your model, even if you use BIM object or not, if you just put some cubes, will be exported. We are a bit short of time, so I can show you there, but I could just place 3 cubes on my document and press the IFC export, and I will have an IFC file with 3 cubes in it. And without having thought about anything about Bing properties, etc. So yes, that definitely, I would say that's one of the strong points of either Freecad or Blender Beam or any other open source Beam application.
Okay, thank you, Juan Pablo, for the last question. And I think we can finish here. And I just want to say thank you, Jorik, for your time, for this amazing presentation. To see Freecad working in a real workflow was amazing. I think that there is a lot of that people can take advantage of this tool that is available to test, to explore, to use, and this talk, this presentation, the idea is to bring closer this technology to the people, especially in countries like Chile or some countries in Latin America. We have people from several countries in Latin America in this moment listening to this presentation, and I think this is a good introduction, so they can start, exploring these tools. And that was the intention, to bring, one of the leaders of that project, who is working to make possible Beam in Freecad. So I just want to say thank you a lot for your time for this presentation, and as well thank you for the Facultad de Arquitectura, Urbanismo y Geografía de la Universidad de Concepción, and as well the people who help us to organize this presentation, the platform. Mauro Fontana, thank you very much. As well, interpreter Carolina. And I think we can organize another kind of instance or event where we can invite you, because you have a lot to show about projects already built with Freecad, like the Week Lab, for instance, or the things. So, but that will be for another moment. So just thank you again. And I don't know if you want to say something to close this presentation.
Just thanks for inviting me. It's always a pleasure to show our baby around. And I hope you guys who are listening are got interested, and just go there, take Freecad, download it, and try. And there is not much more to it than that, basically.
Okay, perfect. Thank you again. And with this, we finish this streaming, and we will see again soon in the next month with another presentation. So thank you again. We can just finish the recording. I don't know, Mauro, Carolina. Oh, interpreter, there is something in. Okay.